Professor T. Pradeep, Institute Professor Deepak Parit, Institute Chair Professor and Professor of Chemistry, Indian Institute of Technology, Madras. Would you talk about your area of specialization and your contribution to the Indian chemical industry?
I'm a professor of chemistry for the past 30 plus years. I work largely on materials. My own contribution, what has gone to industry, is in the context of removing contaminants from drinking water to make it, well, drinkable and it conforming to international water quality standards at affordable cost. This kind of technologies are the need of the hour. In India, as you know, about 110 million people suffer from arsenic contamination. About 130, 140 million people suffer from fluoride contamination. So if you start thinking about India's water crisis, it is exceedingly large. And we don't have affordable solutions. We have solutions. We don't have affordable solutions so that they can be taken to masses. I have contributed to research in this area, not just research. I have taken those technologies to the field, implemented them. Today, those technologies are approved by Jal Jeevan Mission. And today, they are part of what is called the CPHEO manual of our ministry. So as a result, technologies are implemented right from laboratory findings to field implementation, piloting, commercialization. So that's the kind of space that I have worked on.
And what's the technology that you have deployed which is low cost as well as helps in reaching to large number of people who cannot afford it?
This technology basket is broadly called as Amrit, anion and metal removal by Indian technology. So this is called Amrit, and that is how this is branded, and Government of India approved Amrit technology for implementation. So what does it do? Well, if you go and find in the field that there is arsenic in water, here you can implement this solution. So imagine in a village, you are supplying water to 2,000, 3,000, 10,000 people from a water tank, and you find that there is contamination in that water. There you put a small plant. And this plant, materials, the design, all of these came from our research. So broadly, I would say Amrit technology is what we have implemented.
Chemical contributes around 7% of India's GDP. If we take minerals into account, it is around 15%. Do we see moving it to 30% in days to come, in years to come?
We have broadly underestimated the power of chemical industry. This is, as a chemist, this is what I feel. Today, you look at the largest challenge of the world is sustainability. And that's about carbon dioxide or what have you. But that's a chemical. How do you convert that? How do you control it is a chemical industry's problem. We have not looked at enough materials, enough advanced materials, enough naturally available materials in this context. But you look at it, CO2 is naturally fixed by plants, right? That is the most efficient thing that we know about. Is it possible to look at chemical means? Well, oceans fix. That is what is calcium bicarbonate and calcium carbonate. This is how oceans fix. So therefore, chemicals can fix it. Magnesium oxide can fix it to magnesium carbonate. And if this were to be possible, the chemical industry will contribute to sustainability. If you ask anyone outside the street, you ask the question, how would you control CO2? They will not look at, this is a solution that is going to be offered by chemical industry. But in fact, this is what chemical industry can do. And how about energy? How about hydrogen? So if you start thinking about it, this is what chemical industry can do. And if you were to drive your needs in this direction, I would say that chemical industry would contribute even more than what you asked me. So think about energy crisis. Everyone talks about solar, hydrogen, but it is actually a materials challenge. If you talk about electronics, it's a materials challenge. I just now talked about water. It's a materials challenge. CO2, it's a materials challenge. So we have not looked at all of these directions. Those we don't see them as materials technologies, and we don't utilize our materials or new materials in this context. So I suppose this is very much feasible.
What's your vision of Viksit Bharat and road played by your organization, IIT Madras, in making it a reality?
I just talked about water. You see, what a Vikasit Bharat are we talking about if you don't have water for all? What Vikasit Bharat are we talking about if we don't have decent power for all? Decent food for all? So these are all, I would say, what institutions have to contribute to. Just as I contributed in the context of water, there are many other areas that one could have contributed, but I contributed a little bit in the context of water. But every institution should be contributing in very many other areas, and that is the only way by which Vikasit Bharat can be a reality. Think about it. If you have to have roads for all, these roads for all is going to create CO2 at such an alarmingly high rate. And is it not important for us to look at new kind of concrete? Where will this come from? This has to come from institutions. This has to come from new thinking. This has to come from new ideas. Just as years ago, we had 2,000 years old concrete, which did not pollute the environment as we are polluting today. Is it not possible to go back and reinvent something very new, which can be a new binder for tomorrow? I would say that innovation is the key. Our institutions would be or are important in this aspect, but we are not sufficiently encouraging. We are not sufficiently, asking the right kind of questions and funding them adequately. So think about it. If you want to ask this question of new concrete which reduces, let us say, CO2 by a substantial an order of magnitude reduction in CO2, if you were to think in terms of that, how will this come if we don't put in enough resources into it? I would say that if this is possible, India has the right solution. That's all I would say.
In the next 100 years, what technologies, future technologies that you foresee will make an impact?
Nobody can foresee 100 years. I, as a chemist, can see probably 10 years ahead how things would transform. I'm just going back, 25 years back, I could never see the impact of mobiles, right? We could have not imagined at all. I was walking through my paddy fields, countryside, hearing radio from a distance. Never thought that I could talk to my son who is now studying or doing his research in the US. Things have transformed. In the next 5-10 years, I would say that it is going to change by something like 10 times. Chemical industry that you're talking about is going to be transformed tremendously, because in this small room today, we can't probably think of chemicals manufacturing. But in this kind of rooms, I have seen chemical industries flourishing, producing tons of products. So this kind of industry is going to change the world. Artificial intelligence is going to come in a very big way. So in that space, 100 years is too far. In 10 years, what do I see? 10 years, I see medicine coming to you, made by small, entrepreneurs in small rooms. And it's going to be highly personalized. And I'm going to see food coming from factories. I'm going to see carbon dioxide being fixed in the form of food and given to you. I'm going to see air conditioners which not only cool but also remove carbon dioxide. I'm going to see biomass being converted to petrol. So many such things, I see directions of this. But more importantly, I would see life changing tremendously. Healthcare is going to change tremendously. We are now seeing people at 125, right? 120 will become the new life expectancy 25 years from now. This is going to change everything that we are thinking about because their needs are going to be very different. The society is going to be very different. Their expectations are going to be different. Imagine what mobility will be in that world, what communication will be in that world, what entertainment will be in that world. I'm very hopeful that technology is going to produce a whole lot, but I should also say at the same emphasis that this technology is going to create great many inequalities also. Unless we address that inequality adequately with technology, we are not going to create sustainability.